everyone. Welcome back to the Flight Simmer channel. Hope everybody is having a great week. Today, what we're going to do is we're going to talk about stalls, and in particular, we're going to focus on the power off stall. The power off stall is used to simulate coming in for a landing. And imagine if you're coming in for a landing and you come in and you start to do your flare where you make the transition from descent to where you are pitching up the nose so that as you come in, you want to land on your main wheels. You pitch up. And if you are too high above the runway and you have a stall happen, the plane is going to drop, and you don't want it dropping onto the runway hard to where you might do damage to the aircraft and maybe to yourself. So what you want to, it's okay to do a stall. In fact, a good landing does incorporate a stall, but you do the stall just a few feet above the runway so that you come down and it's not a hard landing on the wheels and again, in such a way that you do not do any damage to your aircraft because you're close enough to the ground so that when that stall occurs, it'll just drop and settle right in onto the runway for a much softer and comfortable landing. So we're going to practice the power off stall today. It has several pieces to it. So what I'm going to do is talk about some things as we do this stall, and I'm going to go ahead and resume. So I'm at the Spirit of St. Louis Airport, Kilo Sierra Uniform Sierra KSUS. This is where I'm doing this from. And if you notice at this particular airport that the altimeter has us just below 500 feet, about 406. Did I say 5,000? I meant to say 500 feet if I said 5,000. We're just below 500 feet. And the indication here is we are about 460 something feet. What we're going to do is just round this off to 500 because it's close enough. When we do this maneuver, we want to make sure that we complete the maneuver, this power off stall, above most of the places I'm reading say 1,500 feet above ground level or 1,500 feet AGL. So because we are at 500 feet, we'll add 1,500 feet to that. That's 2,000 feet MSL. However, because the stall involves a descent, so if you see my mouse, you're descending, right? So you're losing altitude there. Plus, with the stall itself, you're going to lose a little bit of altitude as well. So you want to complete the procedure no lower than 1,500 feet above ground level. So that means we would need to complete it no lower than 2,000 feet. And so to add buffer, what you'll do is you'll add another 1,000 feet. So instead of starting the maneuver at 2,000 feet, we want to add another 1,000 to that to give ourselves some buffer, because again, we're losing altitude on the descent. We're losing a little bit of altitude when we have the stall take place. So we're going to start at 3,000 feet by adding another 1,000 feet buffer, so that gives us room, as it were, to stay above that 2,000 feet. So what I'm going to do right now is take off and then talk about some things as we climb to 3,000 feet. And I've got my simulator set to real time, real weather. It is a nice, it's going to be a hot, sunny day here in Missouri, and finding a little bit of wind today as well. And then you can see we are drifting some. I didn't bother to look at the windsock. So I just sort of gambled. There it is. You can see the wind is coming in from our left side, actually coming in at an angle and blowing pretty good today. We actually have an air show at this airport today. The Blue Angels are in town along with a lot of other aircraft, and this is their last day, this being a Sunday as I'm recording this. So, and I'm having to apply some right rudder here because tendency to want to for the plane to want to yaw to the left because of the propeller factor, the P factor, as they say, creating that yaw and high pitch, high power settings. So my nose is up. Now I'm at just crossing 1,500 feet MSL. Before we get to 3,000 feet, I'm going to actually remove, I think I have 10-degree flaps here. Forgot about that. I'm going to remove those flaps. And I want to talk about, I'm just going to pick this altitude right here and let the airspeed pick up and just talk about some things, and then we'll climb again. So right now, if I were to pause, so right now I'm flying level pretty much, except I jostled the plane there. That's because I'm trying to fly left-handed while I pause the aircraft. So let me do that right about there. Okay, so I got it paused. I'm outside the airplane. I'm going to try to come down even with the airplane with the mouse. So we talked about this before, but it's worth repeating because we're talking about stalls. So if you imagine a chord line, it's an imaginary line that runs from the tip of the wing all the way to the end of the wing. Right here, there's a line, okay? And because we're flying straight and level at this point, we have the relative wind. Think of the relative wind as the wind that's coming in directly opposite of the path that the plane is flying. So right now the plane is flying this way, and the relative wind is going to be coming into the aircraft this way, okay? So we have a low angle of attack, which is the difference between the chord line or the angle of the chord line to the relative wind. And so the wind is pretty much flying. It's going over the wings smoothly with no problem, blowing over smoothly, and therefore we get lift generated because of that. And we've talked about that in past streams, so be sure and look at past videos where we discuss this to some degree. Now, if I go into, and you might look at the video on slow flight as well, but if I go into slow flight or I start to slow down, I'm going to go into the plane and take off the pause. So let's say I slow down, right? In order to maintain altitude, I have to pitch up eventually because I'm slowing down. Let's say in this maneuver, we would slow down to 1,500 feet RPM, which means in order to maintain altitude, we're going to have to raise the nose and keep raising the nose and keep raising the nose. So we're pulling back on the yoke, we're pulling back, pulling back, pulling back, pulling back. And let me see if I can hit escape and then pause it. I don't know if I can do this pause thing. Let me try this. I'm going to have to do this left-handed. So we're trying to see how I'm descending. So I'm going to pause it right here. Okay, you hear the stall horn. That's the stall horn warning us that a stall is imminent. So we need to get ready for that. So now look at, you see that we're pitched up, and I'm going to again use the mouse to get this position. So now as we look at the chord line of the wing, right about there. Okay, so we look at the chord line from the starting point of the wing to the tip of the front, tip of the end, right there, and there's an imaginary line. Now notice we're at a higher angle because we have the nose pitched up. However, the here's the stall. The relative wind is coming in this way. We're still flying this direction even though we're pitched up. Okay, so the relative wind is now at a greater, it's coming in, and we're at a greater angle because when you look at the chord line compared to the relative wind, what's going to start happening if that gets to be too great, which is typically, depending on the aircraft, greater than, I don't know about the Cessna 152, but I think it's like 18 to 20 degrees or higher on the angle of the relative wind to the chord line. What's going to happen is we're going to go into a stall because the wind, it starts to separate from the wing. So instead of smooth flow over the wing, you start to get separation. The wind starts to burble, churn, whatever you want to call it. It's kind of, it will not be flowing smoothly. It'll start to separate, and therefore the plane will stall, will start to drop. And usually because the engine, the front part of the plane is heavier, the nose will just drop down. So really, to break a stall, to get out of a stall, the simplest thing to do is to just go back in the plane. Instead of just keep holding the yoke back like this, causing the stall like that, you're going to ease back on the yoke so that you'll just let the plane will just kind of naturally drop. However, you want to try to minimize altitude loss. So the other thing you want to do as you are releasing the yoke like this is you're going to want to add power here with the throttle, your throttle over here. So you're going to push that in to get full power. And then we're going to immediately, we're going to have full flaps when we do this maneuver. We'll talk about that as we get to 3,000 feet. But then you're going to start focusing on flaps. Now you add power immediately again to help reduce the amount of altitude loss. So that's something that's important to keep in mind. And so right now, what we're going to do is we are going to unpause this. I actually stopped, so I'm going to add power. And then pitch back. I don't have any flaps at this point because of the fact that we didn't put any flaps in. Yep. So what I'm going to do is climb. Remember, I said we need to climb to 3,000 feet. The other thing you'll want to keep in mind as we're climbing, I'm just talking about some things. Oh, let me talk about the reason you do stalls in the first place. Really, the purpose is not to get into a stall, but to practice recovery from a stall. So you want to get good at recovery to where you minimize altitude loss, because if you're just a little bit above the, if you're too high above the runway and you stall, you don't have much room to recover from that stall. So you have to act quickly. I'm not going to be able to act as quickly because the way my joystick and controls are, I don't have all the... This is, by the way, one area where I would say it's a good idea to have an actual yoke, because I have a joystick and it creates problems. So if you have a yoke, and then separate from the yoke is your throttle, your mixture, and then your trim wheel, you'll be able to react a lot quicker. So that's the thing. Now, when you get to 3,000 feet and you're getting ready to do this maneuver, you're going to want to pull out carb heat. Let me just talk about carb heat and get it out of the way. Carb heat, you'll pull it out. The reason I'm getting it out of the way, I'm going to deal with ATC here. Very different sounding voice I have. Anyway, you're going to, what's going to happen is when we start the maneuver, we're going to pull power back to 1,500 feet over here on the right side, right? We're going to pull power back to 1,500. And because that's a low power situation, you add carb heat to prevent carb icing from occurring. And so I'm going to go ahead and just pull it. But remember, you would do this at the beginning of the maneuver. So I don't have to interrupt and grab my mouse and pull it. But you would do that at the start of the maneuver. We'll reference that as we get to 3,000 feet MSL. The other thing is, in slow flight, when you do start to slow down, your controls tend to get mushy, not as responsive. And the other thing about a stall, not only will you hear the stall horn, but the plane will start to vibrate. You'll start to feel some buffeting because of that, the fact that the wind, the airflow is separating from the wing, and it's bubbling and churning and all that. And so you'll start to feel some vibration on the plane, and that's also a sign of an imminent stall happening. So here we are. I've gotten off of the westerly course because I'm talking to you guys. So get back over, because I'm going to pick west. So before you do the maneuver, you'll want to do your clearing turns and make sure there's no traffic around. I'm not going to do the clearing turns at this point. We're going to settle in here at this is where I hate the fact that my trim wheel is on the same location, or my trim is on the same location as my throttle, which messes me up every time. So it's very hard to set the trim. So anyway, so we're going about 90 knots right now. It's about good for many maneuvers. A little bit higher than that, that's fine. You're going to, before you do the maneuver, you're going to want to pick a point out in the horizon that you're aiming for. You're going to want to note the, so you're going to look out here. You're going to note the direction that you're going. In this case, west. And then the other thing is you're going to want to pull that carb heat because you're going to be slowing down. So what I'm going to do is I'm going to take this in phases. When you slow down your nose, you're going to be pitching up with your nose. So the reason you want to not only have a point at, or not only look at your heading indicator, which is west, but you're going to want to look out here and note the heading indicator, because as your nose pitches up, you're not going to be able to see ahead of you. So you'll look here, but you'll also look out here in this area where you can see, to make sure that you're not turning, that you're staying straight and level. I'm getting buffeted. The other thing to keep in mind is you're going to have to use rudder at times to stay level. So you may have to you might find yourself using some rudder, and that will come with practice. Just like I said, like when you're in a high power setting and your nose is pitched up, the plane wants to yaw to the left, and you have to use right rudder there. There are times where you'll need rudder to help you to stay level as you're doing the maneuver. So right now we're at 3,000 feet, a little bit lower than that, but that's because I was talking and not paying attention. And I want to add a little power here because I want to get above. Make sure I don't have any flaps on. I don't. Okay. So what we're going to do, let me talk about the first part of the maneuver that we are going to do. And then we're going to break it up in stages. So the first thing we're going to do is we're going to reduce power to 1,500 RPM. The tachometer over there to the right. When we do that, we're going to start slowing down. When we get into the white arc of the airspeed indicator over here, which is not going to take too long, we're going to start setting our flaps to 10 degrees, 20 degrees, and 30 degrees. So we're going to set full flaps. It will not take long for us to reach 60 knots. Depending on the plane, sometimes it's 70 knots. We're going to do 60 knots for this demo. And when we reach 60 knots, we are going to start a descent. We're going to just point the... So before we get to 60 knots, we're going to try to stay level, which means as we're adding those flaps, remember when you add flaps, your plane will want to balloon because all of a sudden you're adding an increase in lift to the plane. So each time you add flaps, in order to maintain altitude to where you don't balloon or go too high, above 3,000 feet, you may have to push the yoke in slightly to avoid climbing too much. So you're going to add those flaps. Keep your eye on the altimeter. You're going to stay at 3,000 feet. And then when we reach slow down to the 60 knots, we are going to start a descent at 60 knots, and we're going to trim for 60 knots. So that's going to be the first phase. We're going to talk about this in phases, and then we'll do another one and put it all together. Okay, so at this point, let's go ahead and do that. So we're going to slow down, look over to the right, you see the tachometer is slowing down to 1500 RPM. We're already in the flaps range, so I'm going to start adding those flaps. 10 degrees, have to push forward a little bit, 20, and then 30. We're already at 60, so I'm going to have to drop. See, we got there faster than I could react to it. Now, we want to descend at a stable 60 knots, try not to deviate from west, and I am going to add some trim here. And again, remember, we're trying to stay above 2,000 feet. So we're kind of at a place where I am going to pause. So we're at that 60 knots. I'm going to stop right there. Actually, we're at 65. But anyway, we are descending. We want to try to get even 60 knots and be stable. But I'm trying to cover some things. Now it's kind of, I don't know if this is just because I've got it paused that's doing that. We'll find out. Because right now it's at 70 knots. But anyway, when we descend at 60 knots, we've trimmed for that 60 knots, right? We're going to pretend like, which is almost immediate because we're very close to 2,500 feet right now. And we could go a little bit lower than that. But what we're going to do is we're going to reduce the power to idle, like we're pretending like we're coming into the runway. So we're going to reduce the power to idle. We're going to start pitching up as if we're doing a flare, like landing. So we'll start pitching the nose up, basically just above the horizon. And when we do that, we're going to see this drop. We're going to hear the stall horn. We're eventually going to hit a stall. And we'll be pulling back the whole time, but not back too far. You don't need to go too far, just where the nose is above the horizon. When we finally hit the stall and it wants to nose over, we're going to release the back pressure with the yoke. Add power immediately. We're going to add power to reduce altitude loss. And then we're going to also, right after that, reduce our flaps to 20, because remember, we are at full flaps right now. So if you see right now over here, we're at 30 degrees flaps. So we're going to reduce to 20. We're going to let our airspeed catch up so that once we pass 60 knots, we're going to reduce our flaps to 10 degrees. And then at about 65 knots, we'll reduce it. Actually, after we reduce to 10 degrees, we'll work on establishing a positive rate of climb, and then we'll shoot for 67 knots to get back to 3,000 feet MSL. So let's try all that as kind of our next big phase. And then, by the way, when you add power, one thing I forgot to mention, when you do add power after the stall happens, you'll push in your carb heat. I am not going to do that at this point because it's just too difficult. because of the yoke, the way my yoke is configured, it's too difficult to reach over and push it in with everything going on. So I'm just going to leave it out. But you would push it in. I might try to mention it as you're adding power. So you add the power, push, reduce your flaps, push in your carb heat, and and uh, and then focus on getting a positive rate of climb again. So anyway, let's try this. I'm going to take it off of pause. Okay, so we've established 60 knots. Now what we're going to do is we're going to go to idle, and then we're going to simulate. Remember, we're going to pull back until the nose is above the horizon there. We're going to hold back, hold back, hold back. Hear the stall horn. It's going to drop. We're going to add power. We're going to reduce our flaps. You would also add your carb heat at this point. We're going to let our airspeed increase to past 60 knots. I did reduce to 20, right? Yes. So we're going to let our airspeed increase to 60 knots. And once we get there, we're going to add 10 degrees. We're going to reduce our flaps to 10 degrees. And then 65 knots, we're past that. We're going to take flaps off again. And we're going to reestablish a climb. At this point, at 67 knots, trim for 67 knots. Remember, at this point, you may have to use right rudder. We're still heading in a westerly. Good thing, because I forgot, as I'm talking to you guys, I forgot to look. So we did pretty well there, even though I wasn't as focused as I should be. And we're at 65 knots. I'm going to drop the nose just a bit. Thought I trimmed. And we're going to let ourselves climb back to 3,000 feet. I'm trying to look out the side of the window and also my heading indicator to make sure because the nose is high, to make sure I'm still heading west. Make sure we're at 0 degrees. We should have all our flaps cleaned up. And we're there, so we're going to start lowering the nose and basically let the speed climb, trim for, you can go ahead and trim for the, I'm going to try to get it to about 90 knots, a little bit faster than that. We're at our westerly direction. We have a spot picked out ahead of us. At this point, you would take out the carb heat. I've already done that because you're getting ready to do the maneuver again. Let's pick up the airspeed a little more. Let's say right about there. Okay, let's try this all in one process, or we're going to do the whole thing beginning to end. So we're going to reduce our power. As we reduce our power to 1500 over here, we're already at the white range. We're going to add our flaps, 10 degrees, 20 degrees. Might have to push forward, which I forgot to do because of the ballooning. 30 degrees. We're already at 60. It didn't take long, so we're going to drop our nose. We're at a little late there. We're going to drop our nose to get a 60-degree descent. 60 degrees. 60 knots. Did I say degrees? 60 knots. And we got our 60 knots. We're approaching you can set your trim here, but we don't have long, so we're approaching the point where we're going to reduce the power to idle. Actually, I was already at idle. We're going to reduce the power to idle. Let me do this over. That was horrible. I want to climb. Sorry, guys. That was a bad. Taking the flaps off. I was way behind. It's hard to talk and chew gum at the same time, they say. So it takes a lot of practice, as you can see. I just wasn't fast enough. And things happen fast with this. So fast I got behind. Fortunately, it doesn't take us too long to climb to the 3,000 feet MSL. Remember, it's 1,500 feet above ground level that you have to recover from. You don't want to go below that in this procedure. We add another 1,000 feet buffer for this procedure that we're following for this power off stall. It's called power off stall. So, trying to get back to west. And almost there. Okay, so going westerly. We're going to lower the nose. Okay, so let's try this again. Hopefully do it better. We're going to reduce our power to 1,500. We're going to start applying our flaps. 10 degrees, 20 degrees. We're going to push forward a little bit because of the ballooning. 60 knots. We're going to drop the nose. Didn't take long. We got a descent established at 60 knots. When we get close to 25, we're going to pretend the airport's at 2,500 feet. Let's say we start flaring too high, so we're going to reduce the power to idle. We're going to start pitching up, and to the point where the nose is above the horizon, we're going to induce a stall. We're going to hold it back. Nose is going to drop. We're going to add power. Ease back on the yoke as you add that power, because you want to get the angle of attack lower so that the wind starts flowing over the wings smoothly again, right? I forgot to reduce the flaps to 20 degrees. You want to do that immediately as well. So after you add the power, reduce your flaps to 20. We're at 60 now, so we can reduce our flaps to 10. Start to establish that positive rate just a bit. As we get past 65, reduce the flaps again. So we're climbing, and now we're going to pitch up for 67 knots. A little bit off of west, but not too bad. I'd have to add some right rudder because we're in a high power situation. So, and what you'll do is, we're heading west. We're at 67 knots. You can trim there for 67 knots. And then you will climb back to 3,000 feet MSL. I've seen, I haven't seen consistency in some of the videos and reading I've done on the recovery from the stall. So some people seem to say, stay even in terms of positive rate of climb, stay at 0, and just go ahead and clean up all your flaps, as you increase airspeed, and then climb. And then some people seem to say, maybe clean up, your first 20, you do the 20 degrees right away, but then actually some people seem to say don't clean up until, but I don't know how you get your, problem is flaps will slow you down, so I think that's why you reduce to 20 degrees first, and that'll help you get some power back as you establish, as you start to pitch up and, you start to pick up airspeed. I haven't seen a lot of consistency. I'm just showing you one way on the procedure after the stall recovery, where you're adding power and all that, and the integration of reduction of flaps. But really the point is, you want to, again, the point of doing stall recoveries is, and I'm just keep climbing, I'm talking to you guys, so I'm not worried about the 3,000 feet. The point is, you want to first of all have a sense of when a stall is about to happen, so you can avoid it in the first place, and that is the stall horn will sound a few knots above the point where the actual stall will occur, the actual airspeed. And then the other thing is you'll start to feel the plane vibrate. That's a sign of an imminent stall. And of course, you don't get that in the simulator, but in the real world, that's what you would experience, and then the stall would occur. So you're trying to avoid the stall in the first place. But then the second point is if it should happen, you want to recover from the stall with as minimal of altitude loss as possible. So try practicing these power off stalls and let me know how it goes for you. And hope you have fun. There are several YouTube videos on power off stalls. So if you want to look at those and see what the real pilots do, it's helpful to watch those. I learn from them all the time. And give it a, once you watch some of those, give it a try in your simulator and see how it goes and have fun doing it. And we will continue with more different types of stalls in our next stream. So thanks for watching.